Yeah, yeah, yeah. Okay, I can do that also. There we go. Yeah. Where it's, meeting materials. Hi. Yeah.
I did a hackathon, but I didn't complete the work that I wanted to do.
Right.
So I don't want to present it, but I want to submit the slides anyways. Can I do that or not?
Yeah, yeah, of course. You can always submit the slides, and then yeah, maybe it will appear here, and I call you. I will call your name. Maybe or not. What's the name of your project?
It's the Opus WebRTC,
Okay,
but
okay.
I didn't complete it in GStreamer, so I
All
it's
right.
very immersive to
Yeah,
submit
yeah,
it.
yeah.
So I'll just submit it.
But well, you not necessarily need to compete. So well, we're halfway, and this is what we're using. Okay, it's up to you, of course.
Okay, right.
I will double check with you. Yeah. Okay. Oh,
Okay.
yeah. Yeah. Sorry. Yeah. Hi.
I just because I had to confirm something.
Yeah.
There is a meeting immediately after in this room that
You're right.
we have to break everything down
Okay.
and
Yeah.
take all the power out and everything. So
Yeah.
if you conclude by 4,
Yeah.
we can conclude by 3:30, even better.
Yeah.
But
Four is really
everybody needs to be out of here
okay.
at 4 because we need to start striking. So if you
Yep.
finish at 3:30, I'm not telling you,
Yeah. Yeah. Yeah.
but
I
it would
understand.
really help
Yeah.
us.
Thank you.
Okay.
Yeah. Yeah. Okay. Okay. Excellent. Yes. Okay. So we're almost ready for the presentations, for the project presentations. The slides are being uploaded, are on the data tracker and now in Meet Echo. Just a brief reminder, there are a number of things. So if you, so you're, well, let's keep the presentations within 3 minutes because we're asked to leave the room at 4 because there's another meeting after this one. So we really have to keep within the time given to us at 4. So we try to keep you to the 3 minutes. The other thing is, if you use the Meet Echo full client on your laptop, don't forget to mute yourself. So you will have convenient the slides in front of you, but mute yourself. So otherwise we get some nasty sounds. Um, I'm just going one by one after the presentations as they appear at Meet Echo. So it's a kind of random order. Other things I should mention, Charles. I think
We'll have a timer for them.
yeah, we will keep time for you and give give visual visual feedback. Visual. Good. The first presentation I like to invite is for the skit project. Yeah. Okay, there we go. Share. Okay, you can use the. Yeah, it's. I think. Hi. Good.
Great.
You can use the mic and just. Yeah, it does work.
Great.
Okay, use the arrows.
And I'm going to start the timer. Let me know.
All right, maybe I can
Do you
try.
see it there?
I do not.
You don't?
Yeah. Okay,
Oh, yes, down
yeah,
there.
Yeah, it's
Yep.
there. Yeah.
Okay, great. So I get to go first, partly because I gave up early, so I uploaded my slides an hour ago. But we got a bunch done, and we're going to keep going. So for anybody interested, working group meeting tomorrow. The fancy slides you'll see here, not in 3 minutes, we'll do in a much longer session tomorrow. So look out for that. But the main thing that we wanted to do, we're whatever 18 months or 9 months old, depending how you look at it, and wanted to really make sure that we can deliver what Skit intended to deliver. So this, of course, isn't everything, but this is our headline statement of what we're actually for, and wanted to make sure that we could deliver all of that. And a lot of this comes around the idea of what's in the standard and what's in the kind of application layers and the rest of the stuff that goes around the standard in order to build useful products. So what we'd planned to do was continue building. We've got an open source interoperability client. We wanted to make more of that so that more people can add implementations and stuff like that. But really looking at how we use it for real world, much more messy things, because supply chains are very messy things. IETF standards tend to be very concrete, formal things, and those two don't necessarily go together terribly well. And we had some hoped for outcomes, which we achieved. So although certainly I didn't personally achieve everything I wanted to over the weekend, we've proven quite a number of points. And the main thing that we were looking to do was to take this thing that Dick Brooks, one of our working group members, provided, a vendor response form, which is part of supply chain attestations for security and compliance, and see if you can actually usefully get that into tooling that's used for software supply chain. And we managed to do that quite successfully. So this idea of splitting out the application layer for things like searching, which is definitely not a semantic property of Skit, and then routing that into formal, crypto and cozy envelopes and stuff like that that are absolutely part of Skit, pretty much worked. So the thing worked is the basic outcome of that. So we did do a number of other things. So AJ, new member of the working group here, has been working on some other use cases for things like software vulnerabilities, and again making sure we get that application and core split done. Hannes has tried the open source client and identified some shortcomings that we need to fix up. But the basic thing that we can discuss in more length tomorrow is, basically everything works. We need to improve the sort of quality and a bit of the precision, but we've got a number of use cases in real world supply chains with application and core stuff pretty much worked out. So successful weekend overall. Thanks very much.
Yeah, just one thing I think we forgot to stress. When you're uploading your presentation, please make sure it's in PDF format, because we need it to be in that format so that it can be pulled in to Miteco and rendered. The CBOR for DNS, I think you guys have it in HTML. If you could redo that one, just re-upload in PDF. Oh, Barry took care of it for you. Okay. All right. Well, thanks.
Okay, thanks. Next, IPMon. Success. You can use the arrow for left and right. Yeah.
Hi, this is ITMon team from SKKU. This is our poster for this hackathon. And this is our hackathon plan for this IETF117. First of all, we tried to make our drone flight more safe this time. So we extended the Semi 5G infrastructure, deploying by G-Node B and ground control system. So through that, we simulated an efficient 5G-based simulation to make drone flight more safe. So in addition, we also implemented drone-to-drone network and drone-to-infrastructure communications. Through that method, we could exchange the lightweight vehicle mobility information. There are two types of message in there. First one is the cooperated context message for mobility information exchange. And another one is the emergency context message for rapid hazardous information sharing. Oh, and this is the brief configure of our simulation. As you can see, there is some ECM and CCM message implementation in application layer. So through that in simulation, we could exchange some vehicle information through D2X network. And through this hackathon, we could learn that 5G cellular infrastructure can be used to handle safety message in the drone network. Oh, slides are done. Oh yeah. So we uploaded our source code and demonstration video on GitHub and YouTube. Yeah, and next. So we are planning to do some implementation, the CCM and ECM as ICMP version 6 neighbor discovery options with IP version 6 over 5G V2X. And this is our team members, and thank you.
One moment, please. All right, complete. And we're back. Okay. Next slides are for Mimi, linearized matrix presentation. Yeah. Success. So you can use the arrows and the time will appear here.
Perfect. Hi, everybody. I'm Matthew Hodgson from the Matrix project.
I'm Travis, also from the Matrix project.
And we'd like to talk about the hackathon we've been doing in integrating Matrix or linearized Matrix, which is a subset of Matrix, with Mimi, which is the working group for more instant messaging interoperability. So just to give a bit more context on Mimi, this is a working group building interoperable messaging around the requirements of the European Union Digital Markets Act, providing a protocol to go and link together the big tech messaging providers. And one of the drafts which we've created is called Linearized Matrix, which proposes a subset of the Matrix protocol that is effectively a hub and spoke model rather than full mesh in order to integrate these service providers together. So what we wanted to do in the hackathon was to test interoperability with the various real-life implementations that exist today, as well as try to figure out where to put the encryption in Mimi, as there is a debate as to whether everything goes over MLS or whether you use MLS just for encryption, and then update back into the drafts based on the above. So there's a quick diagram of what a linearized matrix could look like as a way of linking together the big messaging providers, as well as matrix on the left-hand side as it stands today, and linearized matrix basically being a compatible dialective matrix for the latter. So how did interop testing go, Travis?
Overall, the interop testing went well. There is a YouTube link there if you're interested in seeing Synapse, which is the sort of existing Matrix network implementation, as well as Eigenserver, which is a specific ground-up implementation of linearized matrix. They all work together. We also tested with Android messages from Google, and they're just kind of evaluating it to see if linearized matrix could work or could maybe not work, depending on how that goes. And it kind of went pretty well. So the Android messages interop here, we were able to get it working in at least one direction, specifically from linearized matrix over to Android messages. And we are actively in the process of getting it working the other direction, but it is almost there. But how did the other testing go?
So here we've got a quick picture showing Element Web, which is a matrix client talking to Synapse, the normal matrix server, which is in dual stack mode, then talking linearized matrix through to Eigen server, which is a horrible command line client, no offense, Travis, written in about 100 lines of JavaScript. And so on the Android messages slide, you can see again Element on the left-hand side talking through to real messages by Google or Android messages, albeit with a feature flag turned on. So I'm afraid that isn't available to everybody yet. Also on the layering side, lots of questions in terms of where we put the encryption. It looks as if we might end up with MLS below, but that has a very hard dependency on MLS. So we're going to be arguing with the rest of the Mimi working group in the Mimi session tomorrow. And that's about it. Lots of drafts flying around the place. If you're interested, come and hang out in the Mimi session on Monday or Wednesday. Thank you.
Thank you very much. Up next is, let's see. Okay. The SAF Open Playground. Yep, excellent.
Yeah, hi. I'm online.
Sorry? Remote presenter. Oh, remote presenter. Okay.
Yeah.
Okay, shall I run the slides? I think that's easy.
Yes, thank you.
Or, can I put you in? Yeah, please go ahead. Yeah.
Okay. Hello, everyone. I'm Li Liu. Very happy to share the SAF Open Playground here. Next slide, please. Okay, let's quickly go through the overview of SAF Open Playground, which is abbreviated as SAF-OP. It tries to build a virtualized network platform to enable easy implementation of SAF mechanisms, and it's open source now at the GitHub repository. Next slide, please. Okay, regarding the hackathon plan, we would like to enable flexible deployment of SAF rules based on the SAF information base with SAF information collected from various sources and the SAF mechanisms, such as UIPF-based mechanisms. And we would like to emulate the SAF mechanisms on SAF-OP in the four scenarios. Case 1, limited propagation of prefixes, and case 2, hidden prefixes. Case 3, attacks by source address spoofing within a customer coon, and case 4, attacks by source address spoofing from a provider or peer AS. Next, please. What we had done, we developed a web user interface to easily build and visualize the experimental topology. We built a topology including 5OS on SAF-OP and emulated the network environments and the SAF mechanisms with the specified configurations. We ran the UIPF-based mechanisms on SAF-OP in the 4 scenarios, and we implemented a traffic generator to verify the behaviors of these SAF mechanisms in the 4 scenarios, such as limited propagation of prefixes, hidden prefixes, and attacks by source address spoofing within a customer coon or from a provider or peer AS. Next, please. What we had learned. First, Ubuntu system, we use enables loose UIPF by default. We need to disable it to make the SAF-OP emulation environments work normally. And the experimental results show that the emulated SAF mechanisms have gaps in different network scenarios. We use new SAF mechanisms need to be developed to solve the problems. SAF-OP is a great platform to implement and emulate new SAF mechanisms and can make fair comparisons of these mechanisms. Currently, in some scenarios, the generated traffic not transmitted as expected. We are now still working on this issue. Next, please. Okay, finally, many thanks to our team members, Yujian Shi, Chuan Longli, Hongbin Yang, Lan Chengjing, who is on site now, and Li Chen. Welcome to join us in promoting the project, and feel free to share any ideas with us. Thank you very much.
Thank you.
Thank you.
Okay, can I invite the Young Push integration in Apache presentation? Here in the room or remote? Okay, remote. Okay.
Sweet.
Share. Hi. I can run the slides for you. Please, please go ahead. Yeah.
Okay. I'm happy to present to you our project YAML-Push integration into Apache Kafka, and the people participating in the project are Ahmed El-Hassani from Swisscom, and Benoit Claes, Jean Gilbeuf, and me, myself from Huawei, and Feng Chong from Huawei, and Alex Huan Feng from Insalium. The purpose of this project is to integrate YAML-Push, which is a new way of doing network telemetry, into the Apache Kafka systems. With these systems, it enables us to always validate the YAML-Push messages that contain the telemetry data into the YAML data store by using the Kafka serializer and deserializer. By using the Kafka serializer and deserializer, and we collect data from the router, and then the collected telemetry data is sent to PMACCT. And then we use lib-YAML-Push to pass the YAML notification message and know the main module and its dependencies. And we send get schema request to the router to get the module, to get the YAML codes of the module. And then with this module, with the main module and dependency modules YAML codes, we create schema to send to the YAML schema registry through REST APIs, and then we get the schema ID back. With that schema IDs, we note which subscription the received YAML-Push telemetry message is correspond to. Currently, we focus on step 2 and step 3, which is to collect schema from the router and create schema to the YAML schema registry and get the schema get the schema ID back. Next slide, please. The current challenges we are facing now is find the dependency from through the complicated YAML module dependencies. The dependencies of YAML module includes imports. Imports includes deviates and augments. The first two are direct dependency, while the last two are reverse dependency. So the main module might have include some container in the reverse dependency module, while it does not even realize it. So we need to figure this out, and then create a module for the YAML-Push messages to register into Kafka schema registries. And on the right hand side, there is an example, and we are going to register the schema for from top down, which is firstly B module, and then A module, then A deviation, then D. In this example, we are subscribing to the A container in the A module, and then we're required to fetch all the main module as long as it's as well as its dependencies. Then we're going to register into schema registry. Next slide, please. The current states. Currently, we're able to fetch schema from netconf using libnetconf2, and we are also able to resolve all dependencies and generate payload for the schema registries. And we have implemented a simulator that generates UDP notif message based on net2peer2 and the UDP notif scapits. We're now ongoing there's now ongoing integration with PMACCT, and at the bottom are the drafts that are related. And that's all. Thank you.
Thank you very much. Good. Next up are the the hackathon results from the DNS table. Sure. Okay.
Linksrecht? Okay. Okay. So we had a plan, or at least I had a plan, and some plans emerged during this hackathon. And this is a summary of it. So we worked on DNS out of protocol signaling, which is a mechanism that connects DNS with BGP actions. Right, start announcing the prefix that serves a zone only when the zone is loaded. Handling encrypted DNS server redirection. It's like the 303 response code, redirect response code for privacy DNS resolvers. And we talked about a very old RFC from 2004, already 90 years old, that needs to be updated based on work of a DNS resolver in IPv6 environment, and about a new draft about caching resolution failures. And we had lots of excellent discussion and chit chat and good input for the DNS op work group tomorrow. Also, we had orientation for our newcomer, Barlu Zhu, summarizing current IETF work in the DNS operations group. So fresh blood in the DNS working group, yay! We introduced Momoko Yamamoto with DNS people. I will come back to what she did. What got done? Oh yeah, Momoko Yamamoto has a draft in V6 Ops about DNS resolvers in a IPv6 only environment. And it turns out that the recommendations in this 19-year-old RFC don't hold up anymore. Now we need to update it. So that's really good feedback. And also we talked about caching resolution. There's a draft that suggests that resolution failure should be cached for 5 seconds, but we found out, or we came to the conclusion this is too long. This might be good for you end users, but not for applications. So, final conclusion, what did we learn? It's always DNS. And these are the team members that were at the DNS table. Thank you.
Thank you. All right. Next up is, let's see, the VCon emitter. Yeah, excellent. There we go.
Great, appreciate that. Good afternoon, everyone. We're here to talk about the Matrix VCon emitter. This is dealing with 2 specs here, 2 drafts that we're working on. The first is the VCon draft, which Dan Abley drafted, and the MIMI linearized matrix draft. And this is the second implementation of VCons emitted from a messaging system, the first being one of our partners, Quick. And we were seeking to learn and validate assumptions in the VCon spec through wider implementation. VCons are a new concept around here, so let me just catch you up quickly. The VCons are basically a interchange container for human conversations based to carry human personal details between security boundaries and across networks. And on the right-hand side, you'll see just a quick topology of what we got running here at the hackathon. So we had a Synapse Matrix server that was set up with a server API, application API, and we wrote a node application that would periodically go using that API to create VCons out of each of the matrix rooms, and then push them natively as VCons across the network into the conserver for its use, protection, and interoperation with AI service providers. So what did we get done? We got it working. You can now attach this emitter to any Synapse server, and it will automatically traverse the rooms and create VCons dynamically from what it sees. We have these VCons being created on our boundaries. One thing I want to point out is that unlike other media types like video and audio, messaging does not have natural session boundaries. So we have to pick something to bring their beacons to a close. Quick and other chat systems happen to do that for you through dispositions. So this was the first time we had to do that. We put that there. Actually, also our second implementation of beacons in JavaScript. So that's our second one in the wild. This repo is now on Matrix Beacon Emitter, and we've been testing it. So what do we learn? The first, messaging integration without session management. So we talked about that. We also learned that Google Bard could write a beacon library in a few seconds. By the way, that's not exactly true, but it kind of is. It really helped generate this guy's super quick. And I think this is going to be a point for later on. One other thing in the spec, we noticed that when we started grabbing all the message interactions from Matrix, it became very chatty, extraordinarily accurate, but quite chatty. This might be a really good place to mention the differences between analyses and dialogues inside beacons, where the analyses make it more practical and the dialogues are more factual. And then finally, Dan and I had a good conversation about whether or not we should be putting all the elements inside the beacon, and I think we agree they shouldn't be. But I want to give one sort of quick summary for that. When you give a beacon into like Claude's Anthropic, because all the properties are there, it picked it up immediately. The zero shot on Claude was incredible. You give it a beacon and say, please write me an email of thank you based upon this conversation. It did it right the first time. So that's it. Thank you so much.
Cool. Next is, let's see, that's the VCon, and now we are the multipath quick interop. We're in the room. Excellent. Share. Can use the arrows. Yep.
Hello, this is the multipath quick interop. We have been testing multipath quick. We had 5 implementations on site here, and remotely we had Quiche, Xcode, Pico Quick, Rask, and Ericsson AI Quick. We tested a bunch of features in the MP Quick spec, so connection establishment and negotiation of support, validation of establishment of multiple paths, being able to send data over different paths simultaneously, etc. Also testing acknowledgement of data over the different paths. We also looked at abandoning paths and doing path status messages. So the results is that we had discovered a number of issues in the different implementations and could fix most of them, and we could get interoperability among most of the participants here. And the interoperability looks something like this. We have a matrix here showing various features. We have this path validation, being able to send data, etc., etc. And then we have servers and client implementation testing with each other. So pretty nice results overall. And I think that's good feedback for the work on this MP Quick proposal. And that's pretty much it. Thank you.
Thank you. Cool. We had a quick, and now we are request OTR header, hackathon results. Yep. Hi. Did you give me the slides, Benja? Yep, the slides. These are correct?
They were newer, but it's fine.
Okay, okay.
Yeah,
this
thanks.
is, yeah, you can use the arrows. That's good.
Hey all, I'm Siobhan. I'm Anton. We work at Brave Browser. We've been shipping support for this new HTTP header, and we realized we don't actually have a demo website. So we made that over the course of the hackathon. But essentially, the idea is that if like a site which is sensitive would like return this header, it's a response header, and basically the presence of the header means that the site is requesting that the interaction with the browser be off the record. And this is kind of what it looks like in Brave. But essentially, yeah, you can see that this site, you get an interstitial in Brave, which says that the site may contain sensitive content. And it's kind of like, think of it as a private browsing mode or incognito mode, but tied to one website. There's numerous issues related to like local adversaries that we've heard about and there's research on. So the issue is that often folks forget to be in incognito mode or private browsing mode, and it leads to like over hiding, which is often a telltale sign for an adversary who has access. And this is a problem because browsers or user agents in general typically don't consider local attackers to be in scope of the threat model. So this is kind of an attempt to change things around. And so that's the interstitial. And then I guess in the demo website, you kind of just see the request OTR header. It's just 1 or 0. And then I've just put the 0.0 draft that we have up, which was being proposed in the HTTP working group. And I'll be talking about that on Wednesday. But you just see like there's some UX around that indicating that this website is kind of in like a off the record mode, or like, yeah, it's kind of like some indication that this is a private browsing mode situation and all data will be wiped after the user closes the website or closes the tab, like cookies, autocomplete, caches, all that stuff. Yeah, that's it. Thanks.
Thank you. Good. Next up is the TCOSY hackathon results. Are they in the room? Yep.
Hello. So TCOSY is a open source implementation of COSY, RFC 9052 and 9053, suited for IoT and embedded uses, aiming for commercial quality. This is the same slide from introductory slide from last IETF. The focus since the last IETF is been on elliptic curve encryption. That's ECDH. We've actually switched from implementing HPKE to the ECDH specified in RFC 9053. It's because the customers using TCOSY have SUIT and TEEP have wanted that. So there's been a successful interop test with TCOSY and the COSY working group examples repository on GitHub. So we're doing pretty good there. Just got that running this morning. That was myself, Lawrence, and Hannes doing the work on this. And then there's a hex dump of a COSY encrypt message. Kind of overview of where we are on getting this TCOSY 2.0 out the door. So we kind of have a clear set of features now we're aiming for. And most of that is running. So I'm expecting to do an alpha release of that in the next week or two. I was hoping to do it this time, but it didn't make it. So the last thing coming in was the encrypt with ECDH, and that supports multiple recipients. So then probably 6 months till it's considered commercial quality. And then last, just a note on the algorithms that are supported. The new thing since IETF117 is the RFC 9053 ECDH. And then we've pushed out the HPKE stuff for a subsequent release, so that's postponed. That code's still in GitHub, so it's around. All right, that's it. Thank you.
Thanks. Let's see. Done that. Okay. Okay, next presentation, low latency crypto. Are in the room or remote? Yeah? Okay, excellent. Yeah? Excellent. You're welcome. So, okay, you can use the arrows to go.
Okay. Hi. Thank you very much. I'm Yumi Sakemi from GMO Cybersecurity by ELI. And this is my first hackathon of our project. Okay, I start from background. Recent years, there are new requirements of symmetric key cryptography and hash function. For example, in NIST public comment, the security limitation of 128-bit block size, like ASGCM, becomes concerns. And in end-to-end encryption mechanisms, S-frame, authentication per sender is not provided because of the performance problem of hash function. To solve this problem, we focused on the low latency crypto Arayon. Arayon is proposed by research team of University of Hyogo. Features of Arayon is as follows. Arayon is cryptographic permutation based on AES instructions such as AES and I. And Arayon provides two functions, encryption and hash function. Arayon encryption of Arayon, the size of block is 256 bit, and Arayon hash is the most efficient latency among other hash functions. In this hackathon, our goal is to prepare an environment so as to everyone can try Arayon. So we try to add Arayon into OpenSSL. As a result, we successfully add Arayon encryption to OpenSSL. So you can use new cipher and new cipher suites by Arayon. From the hackathon results, we found that it is worth writing an internet draft from the viewpoint of the high security and performance prospect. This is the next step of our project. Especially, we need to discuss about application, and we believe that Arayon could be useful for the topics in these working groups. So if you are interested in Arayon, please contact us. This is my team member. Thank you for your attention.
Thank you very much. Next is SCHC over IPv6. Probably I have to pronounce it differently. That's remote or in the room? Okay, thanks.
can try to make that quick.
Oh, you can use this mic. Yeah.
Okay. Okay. So SHIC is a compression protocol that was initially designed for use in LP1s, but now we have chartered a new working group to work on SHIC as a general thing over IP or over Ethernet. So in that context, we are defining new protocol types and the ether types in Interia. And now we are looking at how we could place the SHIC compression over IP. So that we started really from the whiteboard. And the context was the SHIC architecture, but also a new draft that came to SHIC about IPsec. We compress IPsec with SHIC. So we needed the general context for doing that for IPsec or anything else. And so the first thing we did really was to define the formats that we would use. And interestingly, we found that we need a SHIC header, but probably that SHIC header will never fly in the air because we are compressing stuff. So it's actually an artifact. So we are defining a header for IPv6 that hopefully will not ever be placed in a packet, though you could on paper. But it's an artifact that will happen during the compression phase. So we define a real IPv6 header, and then we compress possibly this IPv6 header and everything else beyond it. So and then we can place it over UDP or natively. So that's pretty much what we defined. And then the idea was to start experimenting with this on the OpenSHIC implementation. We are not fully done with that, but we have started creating this virtual header inside OpenSHIC to do the compression. So in the end, you end up with a packet which has an IPv6 header, then may or may not have UDP if you need to go through firewalls, and then as the whole sequence of this virtual header plus whatever ULP was plus whatever else, all in the compressed form. So that's a very good base because that was an item we wanted to discuss at the SHIC working group this week. So we'll use effectively the result of the work that we did here as an input to the discussion in the working group. And that's pretty much it.
Thank you. Here we go. The CBOR for DNS presentation. In the room? Yeah, there we go.
Yeah, okay. Hello, I'm Martin. Yeah, my contacts are on the last slide. So, yeah. For this hackathon, I implemented a new content format, application DNS plus CBOR, which is currently discussed in the CBOR working group. The idea is basically to provide a CBOR-based DNS message format for smaller messages in both DOH and DOC. DOC stands for DNS over CoAP. And yeah, there is a draft for it. You can see it there. And our implementation is basically based on Python, using DNS Python for the Python part and CBOR2 for the CBOR part. And the encoder was already there. It just needed some fixing, and but we still needed a decoder, which was actually implemented. So the encoder is now done, but it still needs a larger test vector. The test vector at the moment is quite small. So maybe there's still some fixing to be done. We also found a lib name, thanks to Marco. Before it had no name, now it's called CBOR for DNS. And almost done is the decoder, which can already decode CBOR to DNS, but when you have a packed CBOR packet message, you can't yet decode it. Yeah. We found some issues with the existing draft. So some of the elisions we introduced might need some rethinking because I was not happy about some of the results. And we might need also some dedicated specs for pseudo resource records. So for example, options. So yeah, that's something we need to definitely work on the draft. And then also I made the experience that DNS Python is a little bit hard to work with if you don't just want to parse DNS messages, but only parts of DNS messages or want to generate them. So maybe I will also make a PR to that library to make this public. Yeah, and this also brings me to my last slide. I was alone for this session at least, but yeah, you can find me on the data tracker on GitHub and on Mastodon if you like. And so, yeah, maybe next time I come with a larger team. Thank you.
Thank you, Martin. Next up is the, right. Okay, that's interesting. So it's the quick in space presentation, right? Excellent, success.
Okay. Hello, I'm Mark. So the rationale of this work is to actually revisiting the possibility of using IP in space. Space agencies are actually planning to use IP on moon and planetary bodies such as Mars. Quick, compared to TCP, is actually a good candidate for space transport. Obviously, IP in space has other issues to be looked at, but let's start with transport. Two things that are specific to space communications in general is that you have long delays, from seconds to minutes to hours. For example, Mars is for 4 to 20 minutes one-way delay. And disrupted communications, such as schedule and plan windows of possible communications because of the orbital mechanics. Quick stacks have various assumptions, mostly default constants, that are not suited for this space use case, obviously. An example is the initial RTT, which is usually in the 200, 300 millisecond default, and 200 millisecond in space is kind of too short. So the quick doesn't converge, essentially. There was a proof of concept using one stack from my co-organizer, Christian Itema, who provided very good results in relatively small changes. So that was very encouraging and was done a few months ago. So the plan was to actually work more in terms of modifying quick stacks to be suitable for space, set up a test environment with delays, then learn lessons, and maybe write some documentation or draft about the findings. What we have done, actually a lot and not. A lot because a lot of people came to the table and asked, oh, that looks interesting. And then we started to discuss, space and even, geopolitical problems in space. So most time was spent on having, very good technical discussions on the problem and solution space. Not that much of coding. And we had competition because quick implementers were all in the competitive other tables here on quick. So I suggest to the chairs that the next hackathon, there would be only one quick related project, and I will be the first to come in. So quick implementers may come to my table, to our table. Anyway, even my co-organizer, Christian, who is remote, actually joined the multipath quick table. And that's kind of the list of the people who came in, discussed, having very good comments, and we'll see you next time. Thank you very much.
Thank you. Thanks. Right, we are now here at the L4S presentation. Sure.
Okay, great, thank you. All right, hello. So this was the third iteration of the L4S interop at the IETF hackathon. First two were great successes back in Philadelphia and in London. So thanks to the hackathon organizers for creating great opportunity for us to come together and plug equipment together and run tests. So, and also thanks to the IETF NOC for supporting us with network needs and connectivity and subnets and routing, static routes and all that. All right, so what problems do we work on today, or this time? We were focusing on testing very low base RTT connections. So this is mainly thinking about a fiber or PON network, and where you may have edge compute on one end of the PON and the client on the other, and testing congestion control in those environments. And looking at, are the requirements in RFC 9331 sufficient and provide sufficient guidance for those very low RTT situations. Also, there's quite a bit of work going on enhanced tools for testing L4S with IPERF2, adding a lot of features for measuring one-way delays and round-trip times and providing detailed statistics of that for L4S testing of different congestion controllers. Also, it wasn't planned for this hackathon, but we did do quite a bit of testing of RFC 2322. If you haven't seen the use of RFC 2322 in practice, I highly recommend that you come over to the table and take a look at it. Read up on the RFC in advance so you know what that's about. And our network setup was brought by Nokia. It's a PON emulation test bed. Oops, wrong button. Quick diagram of that. So the PON emulator is in the middle. We have all the servers on the left-hand side and our interconnect to the IETF. And then on the right-hand side are various client devices that were brought by different participants. What got done? Quick bullet points to point out. So we tested 101 simultaneous streamed games in parallel on a 200 megabit per second L4S link. All the streams getting approximately 2 megabits per second and maintaining ultra low latency while doing so. Looked at the low congestion window scenarios and quantization effects with C-wind. We had a bunch of Raspberry Pis that with TCP prog installed, and so that became a nice testing tool for networks. And then all the work on IPERF2, including UDP dissector for Wireshark that was written over the weekend, as well as plans for TCP. And we do plan to move into the Hack Demo happy hour space, so please come over and see us there. What we learned mainly around the congestion, small congestion window scenarios. Mid-window 2 is something that implementers really should look at. Last list of team members, hopefully I didn't forget anyone. Sorry if I did. But we do plan to move into the code lounge and continue testing for most of the week. So please stop by. Yep.
Thank you very much. Okie-do. The FRR presentation. Is it on in the room or online? Oh, yeah. Excellent. Yeah.
Okay, hi. At the FRR table, I'm speaking representative of the patient. By patient, I mean the theme of the table was FRR doctors, the champions being the doctors, and bring your own IETF work to implement. And the project we brought in to have help from the champions was BGP extension for mobile user plane. which is signaling mobile information in BGP, and we have a draft for sending new SAFI information for that. So that was the implementation we wanted to do. What needed to get done was in the previous IETF 116, there was an interrupt for that draft, and it went well for many implementations, including proprietary ones and some OSS. But the FRR implementation, no one was pretty familiar with FRR itself, so this was incomplete. So this time we worked on that. And where we started was in this hackathon. So the work was pretty old, so it's a couple thousands of commits behind the head. So one thing we got done was we got that to the working up-to-date head for the master for FRR. So that's one thing done. And the implementation itself was broken too. So the moment it received the whatever standardized, it just BGPD just died. So we got that part fixed to an extent. So 1 type out of 4 in the draft was completed in this hackathon. So here are the team members and 2 people, me and Takumi, were working on the MUP part. So thanks to the doctors, and that's FRR. Thank you.
Thank you very much. All right. The TLS attestation presentation.
Hey, that's me. I'm online.
It's online. Okay. There we go. I will run the slides.
Sure. Thanks. So yeah, I'm and
Can you maybe speak up a bit? Or...
Sure. Try.
Yeah.
Is that
much better? Thanks.
Okay. Right. So I'm Jonas. I'm here to talk about our work on TLS and attestation, remote attestation, and bringing them together. We've worked remotely for this IETF hackathon. Next slide, please. Right. So our hackathon work revolves mostly around a prototype where we're trying to enhance the TLS 1.3 handshake to allow the 2 peers to authenticate themselves using remote attestation. So using attestation evidence or attestation results as credentials. Effectively, we're working somewhere at the boundary between TLS and RATS working groups, so somewhat overlapping both of them. So we have 1 main working draft, which covers TLS extensions for this type of credential. And we started working on these at the IETF 115 in London and continued at 116. And throughout these hackathons, we've mostly worked on defining and implementing and bridging together the interfaces between the entities in this system. So from the root of trust, which in our case is a TPM, and all the way to the verification service. At IETF 116, we had most of the tester pieces implemented. So we shifted our focus this time towards the verification and endorsement. Next slide, please. So we're happy to announce that now we have an end-to-end prototype that's actually fairly easy to spin up and use. And we've had to essentially implement this time the endorsement and verification steps for the TPM 2.0 based attestation scheme. And we can now provision the identity of the attester to the verifier, and then we can verify the attestation evidence for the TLS endpoint that does the verification. For this, we also needed some more glue layers, particularly around the relying party side, which in our case is the TLS server. And the relying party can now interact with the verification service to obtain attestation results, which it can then parse to obtain the TLS client identity key. We also have packaged all the components in containers and bundled them up together on a dedicated network to simulate the system. Next slide, please. So you can see here the main components for prototype. So we have the attester, which is a TLS client, the relying party, a TLS server, and the verifier. Yeah, we focus mostly on the verification and the endorsement side. And it's worth noting that we still have some lacking functionality that we've left for a future hackathon. For example, in the TLS handshake, even though we can negotiate the attestation scheme at the moment, that's hard-coded. Next slide, please. And what we've learned, so the most important lesson was that we have quite a lot of shifting formats and interfaces, and we needed to synchronize, and there was a lot of effort for that. But at the end of the day, we do have a pretty stable framework that we can use and extend quite easily. Next slide. Yeah, this is our contact details and a few links. Thank you very much.
Thank you. Let's see. Oh, there we are. The BMP hackathon results. Are they in the room? Remote?
Yeah, remote.
Remote.
Yeah. Can you hear me good enough?
Yeah, excellent. Thank you.
Okay, thank you. So hello everyone, I'm Maxence Yunsi, researcher at INSA Lyon. I will present our implementation of BMP enhancements to FR routing. This work is part of a collaboration with Swisscom led by Thomas Graf. Next, please. So BMP is the protocol allowing a router to monitor everything that happens in the BGP process of a router. Its first version allowed to describe the interdomain path received by a box. So that's RFC 7854. It has been extended to describe the path selected as best by the BGP decision process. So that's RFC 9069. And to describe the path finally advertised to the BGP neighbors of the box. So that's RFC 8671. It also provides statistics on the activity of the BGP process. Last but not least, in the FR routing open source implementation of BGP and BMP, we only had the support of the basic version of BMP, so the first one, 7854. Our goal was to bring this up to date with the last RFCs and to provide the first implementation of current working group drafts being standardized at GROW. Next, please. So the result is now the best paths selected by the BGP process are exported by BMP along with statistics. We have routes advertised to the neighbors that are also exported, so the attribute. We do not have all of the statistics for this one because some of them are tricky due to internal limitations of the software. We have a first implementation of BMPv4 TLVs, which allow for a modular encoding of information advertised through BMP. Finally, we also have a path marking draft implementation, which allows for the advertisement of metadata about the logic applied by BGP during the application of the decision process. We have most of the status codes and all of the reason codes implemented for path marking. Next, please. We will be opening pull requests as soon as the FR routing is able to receive them. We will open them for both FR routing features and the Wireshark dissectors that we implemented for BMP TLVs and path marking. If you are interested in this project, feel free to contact us, and thank you. Our contacts are on the first slide.
Thank you. Then we have the SRH results, hackathon results.
Yep, me again, sorry.
Okay, great. There we go.
Okay, so hello again. Still Maxence Yunsi, still researcher at INSA Lyon. Now I'll present the implementation of a Wireshark dissector for SRv6 SRH in IPFix. This work is still part of a collaboration with Swisscom led by Thomas Graf again. Next, please. Okay, so IPFix is the protocol that allows routers to export data plane information about ongoing IP traffic. SRv6 is a segment-based routing protocol that allows to route packets using IPv6 headers extensions to carry routing information. So the drafts in bold draft IETF of IPFix SRv6 SRH. This one allows the router to export information related to SRv6 SRH routing with IPFix. We're using one of the first vendor implementation for the tests, and our project is to introduce support for IPv6 SRH, IPv6 SRv6 SRH data dissection in Wireshark. Next slide, please. The results are that now Wireshark is able to dissect code points 492 through 502 related to the draft in question. The code has been merged into the master branch of Wireshark and will be available in the next Wireshark official release. We tested it using the currently available vendor data, but not all features were available. And some fields still need to be tested. When done, their formatting may need improvement. And sorry for the capture that's not on the slides. Looks like we uploaded all of the slides. Sorry. Thank you.
Okay. Thank you again. We're nearly there. Oh. Then we have, let's see, path tracing, VPP.
Okay. Hello, I'm Laurent from the Host University. Today I'm going to speak about our project that's path tracing VPP. What we wanted is we wanted to implement path tracing in the open source VPP and also improve the open source VPP path tracing implementation and documentation. What was already existing was the midpoint and the sync behavior, and we added the source node behavior during this hackathon into the main line of VPP. What we did also, we added the API functions for the source node behavior, and also we built a lab where we tested path tracing end-to-end from probe generator to probe collector. So just we wanted to, there is a draft about path tracing, and we wanted to do an implementation in the main line of VPIO vector packet processing. So what we got done is that we complete also successful tests. What you see here, we had a lab with 4 ECMP paths, and we were changing the delay of one of the paths to 2 milliseconds and then to 1 millisecond, and you can see that path tracing was reporting this. We are collecting the probes with a collector, and then what we do is that we have a pipeline that is going to process those probes and deliver them in a time series database where we can have a look at the result. What we have learned, yesterday we were struggling with our test because we didn't see all the ECMP path, but at the end we noticed it was a VPP. VPP, something that we had to parameters that we had to change to allow the load balancing to happen. Also what we have learned is that path tracing is working in VPP. It's working as expected. And then, so the team, I would like to thank my team for the great effort. And we are going to be available tomorrow. We are going to present at the ACK demo. And many thanks for your attention.
Thank you very much. Then we have the, I think it's the post-quantum X509 group presentation. Yeah, excellent.
This. Hello, everybody. So yeah, we're the PQ and X509. This was our third hackathon. It was great to get together again. Yeah, so the goals of our project is adding PQ algorithm support to existing X509 structures. That's kind of how it started, 3 hackathons ago. But we're also starting to work on testing and interoperating with new drafts, mainly in the LAMPS working group, but new draft standards that often support migration to PQ. So that's one thing, one of our goals. Also, we provide an artifact repository. So we have a GitHub repository. There's artifacts that people can use for interoperability testing. So encourage you to check that out. There's a link at the end. Also, we provide, or we're working on providing a comprehensive compatibility matrix to show the results. So that's a work in progress. And we also provide feedback to the standards groups about practical usage. And you can see there's a bunch of drafts and we're working on, and we keep adding more. So it's a lot of fun. So what got done? So our group continues to meet even after the hackathon. So we've been having monthly meetings. Those have been attended well. We actually had to stop using Gather because we hit the limit of 10 participants. IETF has a limit, I guess, in the off season that you can only use 10. So anyway, we moved, I think, to Teams now. We've also discussed now having a virtual interim hackathon because we like getting together so much that we thought maybe in September we'll do it again ourselves before the next IETF hackathon. We had some new members join this time. Ali Becker, Brendan Zember, Chris Rodine, Chris Brown, and George Tezopoulos. So it's great to always have new members. So we also tested some new drafts or newer drafts binding for multi-auth certs, so that the implementation have started on that. Interest in there's interest in our group too, developing a lightweight ASN1 parser. So some initial work was done on that. Okay, I know my time's almost up. Thank you. We're working on updates to the compatibility matrix, like I said. One of the new people that joined is also working on integrating some Wolf SSL code. So that's kind of a new provider implementation that we haven't had before. So it's great to have that more diversity there. We've also done some interoperability testing of the Delta certificates draft. And we actually have started working on KEMs, the key encapsulation mechanisms. So we've created some certificates on that. One issue that came up, we discussed a little bit, was about CSRs and KEM POP and what to do with that. So we'll probably use the indirect POP method, where the result that comes back is encrypted, or I guess you could sign it with an alternate key, or perhaps a new draft is needed for that. So some discussion on that, and also some KEM work on CMP updates. So that's some stuff that got done. Things that we learned, so we continue to update our OID list because there's tweaks to the algorithms that happens. And so we learned a bunch of other things. I guess one important thing I wanted to point out that Charles pointed out to us is that because we've been doing implementation works for drafts, we learned that we can actually provide a link in the draft. There's a section in there you can go into, provide a link to where the code is. I think that's important, so people, when they look at a draft, can say, "Oh, there's code," right? So that's one thing that we learned. Yeah, so just to wrap up, we have quite a number of team members. We've had up to, I think, 22 people now. We're going to have monthly meetings, a virtual interim hackathon, compatibility matrix updates, and there's our GitHub page. So come check us out. Thanks.
All right. Yeah. That's for now the last. So maybe I skipped one. So this one. So this one last one. Opus with Dread. Is that here in the room or online? So the WebRTC presentation. No one. I don't see anyone online. Oh, sorry. Yeah. You were not planning to give. Yeah, let's do it. You can do it. That's great. You worked hard.
All right. Okay, so this is an implementation, rather an application of an already existing draft and a wonderful implementation in Opus. It's called Dread. And the use case is that in a network which has a lot of packet loss, how do you make up for the lost packets? So this was proposed, basically a solution is proposed by Dread, deep redundancy, to be part of the Opus codec, which is the default codec of WebRTC. And my objective was to analyze and see if I can implement it in, let's say, GStreamer, right, which has Opus as the base plugins. So these two were my plans. First was to analyze. For analysis, with the tools already inside the Opus repository, I was able to take a data set, run the Dread computation, see the before-after results, hear them, actually, very noticeable difference, and also see the waveform and the scores like PESQ. Although I'd like to add that PESQ scores and the waveforms don't give a realistic evaluation of the quality that this algorithm produces. So it's good to hear it. And then the second part, the GStreamer plugin. This was a lot of work. It's incomplete. It requires additions on the encoder as well as the decoder side. I happen to get through the encoder side, but not as much on the decoder side. The idea is to send a stream in GStreamer and induce a loss of 20%, enable the Dread to work its magic, and then see the output through the other end. So this is work in progress. And I'd like to thank Jean-Marc and Jean Booth from the team that I was part of to help me do it. And these are the links. Thank you.
So thank you. Did I miss someone here? I think we presented all the uploaded presentations. No, then we're complete. Then I like to wrap up. Let's see these slides. I think we want to go here. One moment. This one. So, yeah, thank you all for your contributions and your presentations. Again, I'm really impressed by all the results we have presented and you have achieved here during the weekend. I'd like to thank the sponsors for the running code sessions here. This is Ericsson, Meta, and Icon. They also made it possible. We had nice breakfast, lunch, and dinner. Thanks again. Yeah, we are asked to leave the room before 4 o'clock, so we're doing fine. So also thank the presenters to keep nicely within the 3 minutes. And that's it. I hope to see you all at in Prague for the next hackathon this autumn in November. Oh yeah, and tomorrow evening at 6:30, 7:30, the hack demo happy hour. in Golden Gate 2 and 3. So please sign up if you want to present your, well, give a demo, present your project, etc., etc. Thanks. Thanks a lot.
I saw her coming in. Yeah. I don't know if that other event has anything to do with right now. That's why.
Okay. All right, yeah, maybe the laptop not. I don't know. That's from AMSL, huh? Yeah. Yeah.